Alrighty, let's go ahead and review for the quiz 6.1. So it's a solo quiz. So in this lesson, we're going to go ahead and review the angles of angles of polygons lesson, and also the parallelograms. Really, we're talking about like the properties and such. So the quiz will cover these two lessons. And for 6.1, I'm just going to go ahead and start off by naming polygons, the number of sides, and the number of triangles that they have, if we were to draw it. So let's go ahead and take a look at a triangle. So a triangle looks like this, and it has three, or I should say n equals 3 sides. Okay. And well, if I were to figure out the number of non-overlapping triangles, well, I can only see that there's only one triangle within this triangle, if that makes sense. So there's one triangle. Okay, and then let's talk about a quadrilateral. And a quadrilateral has n equals 4 sides. And then if I were to draw a diagonal from one vertex to another, you can see that there are two triangles. Okay. So let me go ahead and delete this. Move everything up. All right, so let's talk about a pentagon. Should look like this, and it has 1, 2, 3, 4, 5 sides, so n equals 5. And then how many triangles are there? Well, I'm gonna go ahead and draw them from one vertex to another. And we can see that there are 3 triangles, like 1, 2, 3. And then a hexagon, which should look like this. 1, 2, 3, 4, 5, 6. N equals 6 sides. So there are 4 triangles. Okay, so I guess you understand how these hopefully you can see a pattern. That's what I'm trying to say here, because I'm just going to go ahead and tell you a heptagon has n equals 7 sides. You can look up what a heptagon looks like by searching it up. So it has n equals 7 sides, therefore there are 5 triangles. And how did I get 5 triangles without drawing a picture? Well, basically what you have to do is you take the number of sides. So to figure out the number of triangles, you will do n minus, and it's always 2, right? Just like there are 3 sides in a triangle, and you subtract that by 2, you get 1 triangle. There are 4 sides in a quadrilateral. If you do 4 minus 2, there are 2 triangles. If there are n equals 7 sides, you subtract that by 2, and you get 5 triangles. And it works every time without me having to draw a picture. Okay, octagon, n equals 8 sides. So there are 6 triangles. And then a nonagon. A nonagon has n equals 9 sides, so 9 minus 2, that's 7 triangles. And then I can keep on going. Let's go ahead and jump into a decagon. 10 years is a decade, so decade. Decagon, n equals 10, so there are 8 triangles. And you should really, really memorize the number of sides here. And then lastly, a dodecagon. Not n equals 11 sides, it's actually 12 sides. And there are 10 triangles because all I'm doing here is 12 minus 2. Okay, so that's a dodecagon. What if I were to say a generic polygon, which is, I don't know, a 17gon? Okay, there's not a specific name for a polygon with 17 sides, but we just call it a 17gon. How many sides are there? Well, it's in the name, so it's n equals 17 sides, so therefore 15 triangles. Okay, all right, maybe let's do one more. 99gon. So then n equals 99 because there are 99 sides, so there are 97 triangles. Okay, great. Let's go ahead and remember how to calculate the sum of interior angles. Sum of interior angles of a polygon. Remember, if I were to, let me go ahead and draw a picture so you can understand visually. If I were to talk about a quadrilateral, okay, and we can see that there are 4 sides, and then there are 2 triangles because I'm using that n-2 rule. Or I can just go ahead and draw that diagonal, and you can see that there are 1, 2 triangles here, okay? Something that we have to remember, and we've been telling you this a lot, but the sum of interior angles of a triangle is always 180 degrees, right? Because if I were to take a look at this triangle here, this angle plus this angle plus this angle is always going to equal to 180. And in this case, since there are 1, 2 triangles here, that means that the sum interior angles of this first triangle is 180, and the sum interior angles of this triangle is also 180. If I were to add these 2 triangles together, which, will give me this quadrilateral, let me go ahead and spell that out for you, quadrilateral, then we know for sure that 180 plus 180 is what? 360 degrees. That means that this angle plus this angle plus this angle plus this angle adds up to 360 degrees, okay? So basically the formula was I take my 180 times the number of triangles, right? And to figure out the number of triangles, we had to do n-2, right? Because this is going to help us figure out the number of triangles. So the formula that you really, really need to know, and this is so important, is this. It's actually 180 times the number of triangles minus 2, okay? You have to understand how this formula works, and you need to know how to plug it in. Because let's say if I were to ask you, find the sum of interior angles of a, 25gon. Okay, you're not gonna get like a triangle or a heptagon or an octagon, something that's more, familiar. You're probably going to be asked to figure out the sum interior angles of a 25gon. And if you're willing to draw what a 25gon looks like, go for it. But I think it's just easier if you understand and know how to use the formula. Again, it's 180 times the quantity n-2, where n represents the number of sides. So how many sides are there of this particular polygon? Well, we know it's in the name, 25gon, n equals 25 sides. So how many triangles are there? Well, I do 180 times n-2, n is equal to 25, replace, sorry, I was trying to Draw a little arrow there. Replace n with 25, so I get 180 times 25 minus 2. So 180 times 23. So that means that there are 23 triangles. Okay, that means there are 23 triangles. So if I put this in my calculator, the sum of the interior angles of a 25-gon would be 4140. There will be 4140 total. Okay, that's the sum of the interior angles of a 25-gon. Okay, once again, that is the sum. That's the sum of the interior angles of a 25-gon. Now, if I were to ask you, find the measure of each, find the measure of each, or maybe could use the word one or the word in angle. So find the measure of each or 1/an angle of a 25-gon. Because I'm only looking for that one angle. I'm not looking for the sum of the interior angles of a 25-gon. I'm looking for just that one angle. Okay? And I'm not going to draw a 25-gon, but this is what I'm really asking. Right? This is a quadrilateral. The angles add up to 360, but I'm only looking at that one angle. Like, how long is that angle? Okay? And that's what I'm trying to ask you for a 25-gon. So find the measure. Let me see what the quiz looks like so I can ask. Yeah, I would say the measure of each interior angle or something like that. So all you have to do is you're going to use that formula, because we know that the sum of the interior angles of a 25-gon is 4140, right? And to find out, one angle, you would take this and divide by the number of sides. And this only works. This only applies to regular polygons. Remember, regular polygons, all the sides are congruent, all the angles are congruent. So if I want to figure out the measure of each, I would do 180 times n minus 2 divide by the number of sides. So in this case, I do 180 times 25 minus 2 all over the number of sides, so it's 25. And we already know what 180 times 23 is. 25 minus 2 is 23. That's 4140, right? And if I divide that by 25, to find that one angle, that would be 165.6. And that would be your answer, to find that one interior angle. Oh, sorry. Find the measure of each interior angle. To find the measure of each interior angle. Okay? Alright. Let's go ahead and find the sum. So what's the sum of the exterior angles of I don't know, let's go with 25-gon again. Okay, and it's always 360 degrees. 360 degrees, it's non-negotiable. You're not going to change the number. So if you were asked what the sum of the exterior angles of a polygon, you would always say it's 360 degrees. Always. Okay? Alright, I'm going to go back and just re-emphasize that what we were trying to look over here is you're going to find the measure of each or one interior angle of whatever polygon you're being asked, okay? So that's what we did, and we're using this formula, plug things in, and you should get your answer by putting it in the calculator, because there's no way in heck that you know what 4140 divided by 25 is. I can't do that, so I had to use the calculator for that one. Just making sure I wasn't framing my question correctly, but here it is now. So make sure that you understand that what we were trying to do was try to find that interior angle, that one interior angle of, you know, whatever polygon you're being asked. And then over here, that keyword or keywords, sum of exterior, when you see that, it's always 360 degrees. Okay. Let's go ahead and find the measure of each exterior angle. So this is a different question. Find the measure of each exterior angle of a polygon with, I don't know, 25 sides again. Yay. So this is really, I'm referring to a 25-gon. Yes. So then, well, we know that the sum of the exterior angles of a 25-gon or any polygon is 360 degrees. To figure out each exterior angle, okay, that's the key word. I'm going to highlight that, each. You're basically doing 360 divided by the number of sides, okay? And what I mean by, you know, exterior angles, let's say if I were to draw a triangle, okay, and I were to extend that extend the sides here. So this is my exterior angle, this is my exterior angle, and this is my exterior angle. So those things are outside of the triangle, okay? So exterior. To figure out this, we know that the sum of the interior angles of a triangle is 180, okay? But if I were to talk about like a regular triangle, meaning that, you know, some of the interior angles, or no, sorry, if I'm talking about a regular triangle, all the angles are congruent, all the sides are congruent. So this is really an equilateral, equal angular triangle. So this is 60, 60, 60. And, well, how long is this angle here if this is 60? Well, it's actually 120 degrees because these angles are supplementary. They form a linear pair, right? So if this is 60 here, this has to be 120, and this has to be 120. Okay? And remember that the sum of the exterior angles of any polygon is 360, and I know that these three things they have, you know, 120 in common. So if I do 120 times 3, what is that going to give me? That's going to give me 360 degrees, right? So if I want to go backwards and say, okay, how long is this angle if I only know this information here? Well, I'm just going to do 360 divided by the number of sides or angles, which will give me 120 degrees. So let's go ahead and play the same thing over here. Well, I know with a 25-gon, there are 25 sides and 25, you know, angles. So then it's n equals 25, no matter what. So then let's go ahead and plug it in. 360, that's the sum of the exterior angles of any polygon. And I divide by the number of sides, which in this case is 25, or the number of angles, and, you know, that's 25. So 360 divided by 25, that's going to give me 14.4. And I can verify that. Will that give me, you know, 360? I do 14.4 times the number of angles. Will that give me 360? Well, yes, it will. Yep, that'll give me 360. Okay? So that's how you use the measure of each exterior angle formula, which applies to all regular polygons, okay? Let's go ahead and I'm going to take one problem from the notes. And this basically says the measure of interior, sorry, that's not interior, interior angle of a regular polygon is given, find the number of sides of the regular polygon. So what is good? What is given? So we're going to say 108, okay? So the measure of interior angle of a regular polygon is 108. Find the number of sides of the regular polygon. So let me go ahead and break down this question. It says the measure of an interior angle, meaning like if I were to give you a triangle and it's a regular, all the sides are congruent, all the angles are congruent. This right here, even though it's not referring to this, but it's basically saying that one angle, that one angle of this 108 figure, whatever this is it's there. That's like 108 for whatever, figure they're referring to. What you're going to have to do is you're going to read the question, think mathematically, like you're translating words to mathematics. Because it says the measure of an interior angle of a regular polygon is given. That means you're using this formula here. This is the formula for each interior angle. It's 180 times the quantity n minus 2 all over n. And then we use the word is. This word is means equal. And then the given, right, here's the given, should go right here, 108, okay? So then you're going to go ahead and find the number of sides. Find the number of sides of the regular polygon. And we represent the number of sides using the variable n. Right, n represents the number of sides slash angle. So basically what you're trying to do is you're going to solve for n. Okay, so what do I have to do? Well, in order for me to get rid of this n, because now you're going to be using algebra, in order for me to get rid of this n, I got to multiply both sides by whatever appears in the denominator. Okay, so I'm multiplying whatever appears in the denominator, and I got to do that on both sides. So multiply both sides by n, and what do I have? I have n times this whole thing here. Okay, so ignore this. You have n up top and n on the bottom. You're going to go ahead and cancel those two n's out. So you get this now. You get 180 times n minus 2. And you set that equal to whatever 108 times n is, which is just 108n, okay? And then now I look at this, I'm like, okay, distributive property, that's easy. I do 180, oops, wrong color, 180 times n, which is 180n, minus 180 times 2, which is 360, which is equal to 108n, okay? So now I'm going to go ahead and I'm going to minus the 108n on both. Oh, sorry, not 108. I'm going to minus the 180n on both sides. So what's going to go away? This is going to go away. And this is whatever 108 minus 180 is, which is negative 72. So that's going to set equal to negative 72, okay? But what Algebra 1 students forget, and I don't know how they are right now with geometry, because we haven't done the problem like this in a long time, but don't forget to bring down that negative as you are bringing down that 360. So that should be negative 360 on the left-hand side. Oh, I forgot to put n right here. See, I should put the n right there. So then what do I have to do? I'm solving for n, and the variable is on the is on the right side. So I got to go ahead and divide both sides by negative 72. Okay, so that goes away. So I have n equals, what's negative 360 divided by negative 72? That's going to be n equals 5. And remember that negative divided by a negative is going to give you that positive. Okay? Awesome. So that's one way to do the algebra. I'm going to show you the other way because, you know, I do get this type of question asked a lot. So let's do it this way. So it was basically 180 times n minus 2 over n, which is equal to 108n. Oh, sorry, not 108n, just 108. And I'm going to multiply both sides by n again. So I get 180 times n minus 2, equal that to 108n. Then I use the distributive property, 180n minus 360, which is equal to 108n. And then, okay, Mr. N, what do I do? Rather than me subtracting both sides by 180n, if people are used to, you know, moving this to the left-hand side, you can definitely do that. So what I mean by this is you're gonna get something like this: 108n, and then 180 minus 108n. All right, I'm looking at this. That's going to be what? 72n minus 360, which is equal to, what's 108n minus 108n? Well, that's going to be 0. And then if I add both sides by 360, because now I'm going to go ahead and do, I just want to get 72n on the you know, left-hand side just alone. That's going to be 72n equals 360, and then you're going to divide both sides by 72, so n equals 5. Okay, so there are, you know, two ways to do or approach this algebra problem, just how I did it over here. Okay, hopefully that clears everything up. So yeah, that's how you're supposed to do that type of problem there. Make sure that you are paying attention to the words there. So yeah. All right. I'll go ahead and take a look at lesson 6.2. That was just lesson 6.1. My goodness, that took forever. 6.2, in which dealt with parallelograms. Okay. So it's so important that you understand the properties. Just understand the properties of parallelograms, which one of them was opposite sides are congruent, opposite angles are congruent, consecutive sides are supplementary, and then if you have a parallelogram, if parallelogram with one angle being right, then all angles of that figure are right as well. Okay? So if I were to say, something like this, suppose that you have a parallelogram. So given a parallelogram, find x and y, and let's say you have this figure here, and this side is 4y minus 9, 5x minus 2, and 2y plus 5, and this one is what, 3x plus 4. Okay, so what I'm trying to say is this is how long this side is, this associates with this associates with that side, and this associates with that side. Okay, and you know that this is a parallelogram. This is a parallelogram, meaning Opposite sides congruent, opposite angles congruent, consecutive sides are supplementary, and if the parallelogram with one angle is right, then all the angles are right. But in this case, we don't see a right angle at all, so it doesn't matter about that one. But we're dealing with sides here, so let's go ahead and use our tick marks. We know that opposite sides are congruent, so that side, that top and bottom are congruent, and the sides left and right are also congruent. So then what do I do to solve for x? Well, we understand how geometry works. If things are congruent, and you set them equal to each other. So I do 3x plus 4. I'm trying to figure out what this side here is. And you want to set that equal to this side here. And then what do? You're going to get 6 equals 2x. And then x is equal to 3. And then over here, I'm going to take this top and bottom and set them equal to each other. So 4y minus 9 is equal to 2y plus 5. So you get 2y equals 14. So y is equal to 7. Okay? And that's basically me solving for x, or sorry, this is x and this is y. And if I were to ask you, okay, how long is this side here? Well, I know that x is equal to 3, right? So I do 3 times 3 plus 4. That's 9 plus 4. That's 13. So this side is 13. And since the opposite sides are congruent, this is also 13. And then you're going to do the same thing. If I want to find this side, I would do 4 times 7 minus 9. 7, 14, 21, 28 minus 9. Isn't that just 11? No, it's not 11. What I'm doing? That's not 11. That's crazy. I cannot do arithmetic in my head. So that's actually 19. Okay, so this is 19. So, yep, that's 19. And this is also 19. Dang, I should have just plugged it in here. This is much easier to do in my head to do this, but that's also 19, okay? So basically, you're solving for x and y, and if you're asked to, make sure that you plug it in, you're evaluating so you can figure out what the actual measure of that side is, or all the sides. All right, so let's go ahead and do one more where the angles are congruent. So given a parallelogram, I'm not going to write the whole thing, but given a parallelogram, find x and y. This is 56. That angle is 56. This is 5y minus 26. And then this is 4y plus 4. And then this is 7x. Okay, so given a parallelogram, remember, what's one of the properties? So I can see that we're dealing with angles, and opposite angles are congruent. So then these angles here are congruent. So I'm going to go ahead and draw my arc. So one arc here and one arc here. And then these angles here are congruent. So I'm going to go ahead and draw my arc. So 2 arcs here, 2 arcs here. So 7x equals 56. Those two things are congruent. So x is equal to 8. And the other one would be 4y plus 4, which is equal to 5y minus 26. And if I were to do the math, I'm going to add 26 on both sides minus the 4y. So you get 30 equals y. Okay, that's my answer. And if you were to plug it in, well, you know what x is equal to. You can figure what this is. Actually, since these angles are congruent and this is just a lousy, regular number, this has to be 56 as well. Okay, if you were to plug it in. But for these two things, I'm going to plug it in here because that looks easy to do in my head. So 4 times y, which is 30. 4 times 30 plus what? 4? That's, that's 120 plus 4, which is 124. So these angles, they are 124 each. Okay? All right. That's all from me.